Hello Math 3 students, this is your 4.2 Edpuzzle video. So in the last section in 4.1 we talked about transformations, and that's really what we're going to focus on today as well. We're going to be focusing specifically on this 1 over x function. All right. So it says in 4.1, winner, you were introduced to the function y equals 1 over x. Before exploring the family of related functions, let's clarify some of the features of y equals 1 over x that can help with graphing. Here is the graph of y equals 1 over x. Use the graph to identify each of the following. So it says horizontal asymptote. So horizontal means this way. I'm sure you guys probably know this, but if you get horizontal and vertical mixed up, I was always taught like the sun comes over the horizon. So that's how you know it's side to side, if you ever get those kind of confused. So the horizontal asymptote is going to be the one that goes from right to left, okay? Now, lines that go right to left are always going to be y equals. On this parent function, okay, the horizontal asymptote is here at y equals 0. All right, it's this guy right here. So you would say y equals 0. How do we know that's an asymptote? Well, you can see both sides of the function approach 0. All right, but you can see that it's never going to touch 0. If you go into the negative direction, you go into the positive direction. They both get really close to 0, but they do not touch 0. So that is how you know you got a horizontal asymptote. Now for the vertical asymptote. Vertical is going to be up and down. All right. Our vertical asymptote is going to be x equals 0. Lines that go up and down are always written as x equals. So our vertical asymptote is x equals 0. And you could again see that as the function approaches 0, it gets really high, right? It doesn't touch 0. As the function goes to 0 from this side, it also reaches an asymptote. All right. Then we've got anchor points. All right. So let's look. We've got the point 1, comma, and that's going to be 1. All right. And look at the graph. It's -1, comma, what? Look at the function. Finish up this point. -1, comma. That's going to be -1, comma, -1, right? Ooh. This guy, -1, -1. That's your point there. All right. Then we've got 1/2, comma. So if we go to 1/2, it's going to be comma 1. 1/2, comma 1. If we go to -1/2, what do you get? It's going to be -1. All right. And if you go to 2, you get 1/2. If you go to -2, what do you get? You should get -1/2. All right. So these are kind of our points that give us a sense of what's going on here. So now let's go ahead, we'll take a look here at number 2. So it says, in each of the following problems, you are given either a graph or a description of the function that is a transformation of y equals 1 over x. Use your amazing math skills to find an equation for each. All right. So let's go ahead, let's take a look here. So if we look at the graph at number 2, you can clearly see it looks a little bit different than this parent function. I will tell you, one of the biggest pieces of information you're going to get is what happens to the asymptotes. All right. So if we had to draw on our asymptotes here, our vertical is still at x equals 0. But our horizontal is now at y equals 5. So what happened was our function got moved up 5. All right. So when that happens, that tells you that you're going to have a transformation that essentially pushes the graph up 5. All right. And the other thing I want to point out, this is kind of your giveaway here. We know that we can have stretches and compressions. You have to use these anchor points to help you with the stretches and compressions. This one's going to be very helpful, right? We know that typically we go from the center, where those two asymptotes meet, up one, over one. That's where the point normally is. And if we look on this graph, we have our center point where the two asymptotes meet, up one, over one. So that tells us that we do not have a stretch or a compression. If that point moved, then we would have a stretch or a compression. All right? So the only transformation this guy had was that he was shifted up 5. So in order to write this equation, we just need to take the original function, which in this case was 1 over x, and shift it up 5 vertically, which is going to be that. So this would be our equation. Now let's go ahead and try number 3. So this looks pretty similar to this one, but if you notice, the original function looks more like this, right? So something definitely happened. So first, let's go ahead and figure out if we had any vertical or horizontal shifts. Our horizontal asymptote is at y equals 0. So that tells us we actually didn't shift up and down at all. Our vertical asymptote is at x equals 0. So that tells us then that there is no right-left shift. Okay? But you could tell that this is kind of like there was a reflection, right? And actually, you could either say that there was a reflection over the x-axis or a reflection over the y-axis. It's going to be the same thing in this instance, all right? Because you could tell, like, you could either say, like, this guy was reflected over this axis and drawn here, or it was reflected over your y-axis and drawn here. In this case, both kind of reflection is going to give you the same function. Basically, the way that you show a reflection is just slapping a negative sign out in front of the function. And this would be your answer. And, of course, we need to check for I forgot to do that. We got to check for a horizontal and vertical, we have to check for a stretch or compression. In this case, again, there is no stretch or compression because we've got 1, 1. Right? Move over 1, down 1. All right, so now we've got number 4. The function has a vertical asymptote at x equals -3 and a horizontal asymptote at y equals 0. It contains the points -2, 1, 4, -1, and the intercept 0, 1/3. Okay, so there's a lot going on here. Let's go ahead and draw a graph. And we'll go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. All right. Not perfect, but it'll do. And now let's go ahead. I'm going to use a different color to graph. So it says we have a vertical asymptote at x equals -3. So our vertical asymptote is actually going to be right here. All right. And a horizontal asymptote at y equals 0. All right. So that gave us our 2 asymptotes. So you could definitely tell that there's some shifting going on here. Specifically, right, the asymptote that used to be right here now moved over 3. Now it says it contains the points -2, 1. So we've got a point there, and -4, -1. All right, and then it tells you that your y-intercept is 0, 1/3. So I want to look at these points specifically, right? We talked about how when there is no stretch or compression, all you need to do is go where the 2 asymptotes meet up and go 1 and 1, and you should hit a point. If you don't, that tells you got a stretch or compression. Here, if we go to our center and we go 1, 1, we hit our point. So that tells us that there is no stretch or compression. We are going to do some problems where there is a stretch or compression, but not yet. I should say just not this one. So we go ahead and draw that in, and this is what our function would look like. So now let's talk about what happened. There was no shift up and down, right? If there was a shift up and down, this guy would have moved, our horizontal asymptote. That did not move, so there is no vertical shift. Or I should say no shift up and down. I feel like that'll get confusing. So no shift. But we moved 1, 2, 3 to the right. I'm sorry, 3 to the left. All right. So if we moved 3 to the left, that means that, you know how when we go left and right, it goes the opposite, right? So we technically moved in the -3 direction, but when we go left and right, we always flip-flop. So we're actually going to do a +3. So we're going to say y equals 1 over x plus 3. All right. This was the same with parabolas. Remember when you move left and right, you do the opposite of what you think you would do. So since we moved -3, we're going to do a +3. All right. And then there's no stretch or compression. All right. So now let's take a look at 5. All right. So first we see that there is a horizontal asymptote at y equals 0, which tells us that it did not shift up and down. Okay. But our vertical asymptote is now at x equals 2. Okay, so we did move right 2. Then we got to look and see, was there a reflection? There is no reflection here. If there was a reflection, our graph would look like that. Then we got to check, was there a stretch or compression? We go to the center, 1, 1, we're good. All right. So now the only transformation we have is right 2. So I want you guys to keep in mind, I'm going to help you out here. This is our parent function. If we want it to shift up or down, right? Let's say we wanted to shift 5 up. We do 1 over x plus 5, right? That shifted it up 5. Okay? If we want to shift it left and right, we got to add things to this bottom, right? Here, we shifted it left 3, so we did plus 3. So I want you guys to think, if we're going to shift it right 2, that's the only transformation, right? Here, our only transformation was left 3. We're moving right 2. What would this function be? Think about that. What would this new function be? So the new function would be y equals 1 all over x minus 2, right? That minus 2 is your right 2. All right, let's go ahead and try number 6. So it says number 6, the function has a vertical asymptote at x equals 0, a horizontal asymptote at y equals 0, and it contains the points, and then it gives you all these points. I'm just going to go ahead and draw the graph and then put them in. So we've got, just draw in our axes, and we'll go 1, 2, 3, 4, 5. We'll go 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. I'll graph in a different color. We have our vertical asymptote right here and our horizontal asymptote right here. So you could tell right away that this thing was not transformed left, right, or up and down because the asymptotes are where they are in the parent function. Now let's go ahead and plot the points that they gave us. It says it has the point 1, 2, -1, -2, 2, 1. And actually, real quick, this is a typo. On the publisher's part, this should have been a -1. It's an odd function, so that point wouldn't make sense. So we'll go -2, -1. All right. Then we've got 1/2, 4, and -1/2, -4. All right. So our function looks like this. It looks very similar to the parent function, but something's a little bit wonky, right? Remember how I said you need to go to the center where the two asymptotes meet up and go over one, up one, right? This guy does not do that, all right? He goes, if you go to the center, he goes right 1, and then up 2. Now, since that goes up 2, that tells you that the function is being multiplied by a factor of 2. AKA, there is a stretch by a factor of 2. So the way that you would write this function is y equals 2 times 1 over x. Another way you could write this, probably the more common way and probably the way we're going to use and that I would put on a multiple choice test, is y equals 2 over x. That's just if you multiplied this out, right? You multiplied the 2 with the 1 over x. You would end up with 2 over x. So this is really what you're going to want. But be aware that it is equivalent to this guy. All right? Cool. So let's go ahead. We'll try number 7. So for number 7, we have our horizontal asymptote at y equals -4. We have our vertical asymptote at x equals -1. So we do have definitely a some shifting going on here. All right. So this y tells us that we went down 4. Okay. This x tells us that we went left 1, right? We would have started out here. We went down 4, left 1. Now let's go ahead. Was this reflected? No, this one wasn't reflected. Then we can, how do I know it's not reflected? If it was reflected, we would have our graphs in these quadrants. Then we can check for a stretch or compression. If we go to the center, right, up 1, there is no stretch or compression. So our two transformations are going to be left 1 and down 4. All right. So if you recall, the left and right, we deal with by the x, right? We either have to add or subtract. Left and right tells us that, or I should say when we go left and right, we kind of do the opposite, right? So it looks like we went -1, but we're going to put a +1. Then up and down, we just do what we think it should be, right? So if it's down 4, we're going to do a -4 on the outside. So this would be our equation here. All right.